So I may not be in the office the whole full time, but usually that meeting's in the afternoon, so it shouldn't mess with my office hours on Friday morning. All right, we are recording, so let's get started at the current slide. But we won't be starting in this yet. I'll go up. Section 4.4 is rational expressions. We're not quite ready for that yet, but we'll get there. Let's finish 4.3. Sorry, I've got some congestion, so I'm not speaking too well. Any questions on anything we've covered so far? Okay. Where we left off last time was example 9, and I'm pretty sure I'm remembering correctly. This wasn't on the slide set, so we're going to do it on, actually I think this next page will be better. It has a little more white space at the bottom. Okay, so example 9 it says to add, let me get my pen activated. This is on page 199. It's chapter 4, rational expressions, 4.3, adding and subtracting rational expressions, and example 9 is add this rational expression. X over x minus 3 plus 4 over x. Okay? Now, one of the things I typically say, and I don't always, but I usually try to think it anyway. When I look at a problem like this, one of the first things that pops into my mind are what values of x do we have to exclude here in this problem? What value of x do you not want this to have? Okay, 0 for here. You can't divide by 0 here. How about here? What would make that denominator 0? Positive 3. 3 minus 3 would be 0. Okay? So, I don't always write it, but I'm going to this time. Over here on the side, x cannot equal 0 or 3. Okay? Just for... I forgot to call roll, didn't I? I'm sorry, I was so busy setting this up. Kristen... sorry, I can't talk, is here. And by the way, there's just 2 shopping months left till Christmas. It's scary, isn't it? Okay. All right, Donna's not here yet. JT is not here yet, is he? I haven't seen him yet. Minuet's not here yet. Oh, there you are. I was looking for you over there. Sorry. Okay. And with the hat on, I didn't see you. Sorry. Okay, Andrea, not here yet. Jasmine? There, okay, got it. Saw you earlier. Okay. CJ is not here yet. Eason is here. Kenesha is here, right? Yeah. Back in the corner. Tadarius, not here yet. Oh, are you? Okay, I'm sorry, I saw you come in. Okay. Decime, not here yet. I was going on to Decime. Seth is here, right? Seth, right? Yeah, okay, good. Make sure I'm not getting things too well today. Chris is not here yet. Taylor is here. Okay. Jalen. Oh, right here, sorry. What's the problem is I've got a Jalen in my 8 o'clock one. She sits back there, so I look up here every time. I look up here in the Tuesday, Thursday class, I look back there and I got it backwards. Sorry. Justin is here. Okay. Nick just came in. Melba. She never misses. Okay, not here yet. Tara's not here yet. Aria is not here. Oh, there you are. Okay. Tequila. Got it. Thank you. Lindsay's here. Summer, I don't think she's still on the roll, but I don't think she's in the class any longer. I just don't know. Jay just came in. Michaela is here. Good deal. And Essence, not here yet. Jayla Webster, not here yet. Brianna is right there. Okay. And Chuck has not come in yet. Right. And Tamarcus, not here yet. Okay. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 2, 4, 6, 8, 10, 12, 14, 16, 17. Got it. Okay, sorry, I forgot to call roll earlier. All right, we were working on this problem, and we said right off the top, this is on example 9 in chapter 4, rational expressions, 4.3, adding and subtracting rational expressions, on page 199, bottom of the page, example 9. X over x minus 3 plus 4 over x, and we noted x cannot equal 0. Webster. Yeah. Okay? And x cannot equal 3. Okay? What's your first step? After we noted that, what should you do next? Say again? No, this is addition. Okay. You may multiply something. What were you thinking of multiplying? 3 times 3? Or x times 3? What did you say?
3 times 3.
Not 3. Okay. What we need, this is an addition of fractional forms. What do you have to have before you can add 2 fractional forms? Yeah, the same denominator. We don't have the same denominator. So what do we do to get the same denominator? Okay, say that one more time. Okay, did you say x minus 3 on the other side? Is that what you said? Okay, thought you did. Okay, all right. What I understand her saying is these are not numerical denominators; they're variable denominators. So basically, and there's no common factors, so the common denominator is going to be the product of the two. So that's what I was hoping you were going to be multiplying. Multiply the two together. Okay? You want an x over here and an x minus 3 over there. So to get an x here, what are we going to have to do to the numerator? Multiply by x as well, making us an x squared there, right? Okay? And to get an x minus 3 down here, what do we have to multiply by? What do we have to do to the numerator? Help me, help me. Also multiply by x minus 3. I say 3 and write 2, okay? Multiply by x minus 3. All right, what have we got in the numerators so far? We got the same denominator, so you can put all over that common denominator, x times x minus 3. What's in the numerator? X squared. Say again. Plus 4x minus 12. Excellent. Okay? Are we through with the problem? We may be. But what should we try? Yes. Question.
Is my x squared plus 4x?
X squared. Yeah, I said it, but I didn't write it. Sorry. X squared plus 4x. Okay? X squared plus 4x minus 12. Now, what do we need to investigate? See if we can factor the numerator. It may not help us any, but let's see if we can. If it's factorable, what would be those factors? Or at least the beginning of them. What's the first term going to be? X times x, okay? How about the sign of the last term? What is it? Negative. What does that tell you about these two signs? They're different. One positive, one negative. Now, what are two numbers that multiply to be 12, but their difference, because they're different signs, their difference is 4?
6 and 2.
6 and 2. Okay? Which one is the plus, which is the minus? X minus 2? Is that what you said? Yeah. X minus 2, X plus 6. Because the middle term is positive, so you need to be at the bigger term, bigger number being positive. Well, let's check it and see. X squared minus 2x plus 6x minus 12. Minus 2x plus 6x plus 4x minus 12. Yep, that works, and it didn't help us a bit. Okay? So therefore, this answer is just as good as that one. So either of those answers should be perfectly fine. Okay? They did factor, but they found out just like we did, it doesn't help to factor, so this answer is just as good as that one. Okay, JT is here. All right. Anyone else come in since I called roll? Okay. Any questions on 9? Okay, we're doing example 10 in chapter 4, rational expressions, 4.3, adding and subtracting rational expressions, example 10 near the top of page 200. So I'm going to clear the slide here, and let's do example 10. All right, here's one. 2x over x plus 1 minus 3. All right. Now, as we did before, what's one thing you might want to note here? X can't be. Say again? Okay, the denominator can't be 0. What would make that denominator 0? Negative 1. X cannot equal negative 1. We may not need it, but just in case, cannot equal negative 1. Okay? Now, what are we going to have to do this subtraction? What do we need to have? Say again. Same denominator. And we only have 1, so we know this denominator has to become an x plus 1, right? But if you multiply the denominator, what was the denominator before? 1. Multiply that by x plus 1, that means you have to multiply the numerator by x plus 1. Okay? So now we got our denominator, x plus 1. What are our numerators? The first one doesn't change. 2x, say again? Minus 3. Minus 3x, and then minus 3 times of 1 is negative 3. Perfect. Okay? Melva decided to show up today. Were you stuck by that accident? 2 of them? Oh no. There was one when we came by, and there was you came in 2059 from the east, yeah.
Now it's 3 going up.
Oh my goodness. What is it? Today was a nice day. Why is there so many accidents? Okay. All right, let's continue. Are we through with the problem?
No.
What do we need to do?
Subtract.
Subtract what?
2x minus 3x.
And what does that give you?
Negative x.
Negative x minus 3 x plus 1. That is a perfectly good answer. There's nothing else you can do to that problem. Now, there's one thing you may want to do just to make it look a little better, but it really doesn't help much, is that numerator you could factor out of minus 1. Make it minus, and that'd be x plus 3 over x plus 1. But again, that's no different from that. Both of those answers are correct. They didn't even do that second step. So they ended with a couple fairly simple examples. All right, your conceptual quiz is always true-false, 10 true-false questions. I would definitely do this just to see if you got the concept right. They're real easy to check because you flip over one page and there's the answers on the next page. So do the concept quiz. Homework exercises, these are much more important to do because these are going to be more like your quiz and test questions. Any of the odds 1 through 11. Any of the odds 13 through 65. There's a whole passel and a half of those. And then 67 is a good problem. And that's about all, okay? Now 67 is a little more abstract. Well, actually it has 4 parts, so you might try 67. Any questions then on 4.3? Now before I forget it, I think I marked everybody since they came in. Let me make sure I did get your quiz. I know I sent it down to be copied. I may have even copied it myself. Yeah, there it is. Okay. Now, most of the time I make quizzes 1 page, but this was one that was from the test bank, and I could not get it to get the 10th question on the same page. If I could have retyped it, I said, nah, I'm not going to. So, anyway, that's why it's a 2-page, but it's only 10 questions. Okay. One and pass a couple. One and pass 1. Okay. One and pass 3. Okay, so that's right. So 1 more. Okay. Keep 1 and pass 4. And keep 1 and pass 3. Okay. So these are books that aren't here. All right. And these are based on the first 3 sections of first 3 sections of chapter 4. All right. Now, if you have any questions about them, bring those questions in on Monday, and I'll answer any questions you may have there. Now, if it's just to explain what I'm looking for or something like that, yeah. But if it's how to work it, nah, I'm not going to work the quiz question for you. But find any one of them like it's in the book. I'll work anything in the book as long as it's not exactly the same question. Okay, any questions on that? It's due a week from today. But if you need more time, that'll be okay too.
But you can turn it in earlier, right?
But you can turn it in earlier. If you finish it this weekend, turn it in on Monday. That'll be fine. All right. Let me also say this, since we got your time. This class has been one of my best one about getting papers in, research papers. I've gotten 1, 2, 3, 4, 5, 6, 7, 8 in from this class out of 28 students or something like that. So that's not bad. But notice we are in the second half of the term, so please don't put it off too long. If you haven't got your paper in, please work on that. Your first quiz, there's just 1, 2 people haven't turned that in. I have my doubts that one of them is even going to continue. Oh, look at this, another paper in, all right. I have my doubts that, oh goodness, 2 of them. They're coming in droves. Come on, keep it going. Okay. I don't think one of these people is coming to the class anymore. I know she's not coming, but I don't think she's in the class anymore because she's still indicated it's not paid, and they were supposed to remove non-paid students from the roll. I don't know why she's still in it. But the other person hasn't been here in weeks, so I'm guessing both of them, but she hasn't withdrawn yet, so I can't return them until I know. I don't want me to return them, and then the next week she shows up and turns in a perfect paper. Now, I don't know whether she knew it that well or she saw someone else's. So those 2 still haven't done the test, which I'm not expecting them to if they're not going to be here. But I've got 1, 2, 3, 4, 5, 6, 7, or maybe 6 others who either turned in one that I'm not sure you're through, or you haven't done it at all. So if you haven't done the test or you're not through with the test, here's what I say. Look on Blackboard. If you don't see a score there, but you know you did the test, that means I'm not sure if you're through or not. And if you are through, just let me know and I'll record the grade. But I wasn't sure if you were finished or not. If you haven't finished it, then haven't done it, please come and take the test. Okay? So I'll try to get those back as soon as I know on the other students. Okay. All right. And then this one is due within a week, but you can take longer if you need it. Now, that's why I don't like you having, not getting the stuff in. You have gotten your stuff in, but the people who haven't, because that prevents me from giving back the other people. And you need to see what you did on your first test before we move to the second test. So please, folks, if it's you, I don't think it is, it's probably other folks, please get your, encourage them to get their work in. Okay, let's go back, and we are beginning 4.4. It's still Chapter 4, Rational Expressions. Chapter 4.4 is more on rational expressions and complex fractions. Now, I don't like that terminology, though all the math books use it. In mathematics, when I think complex, I think it has imaginary numbers in it. That's not what this is talking about. I think a better word for it, for me, I consider them complicated fractions, meaning fractions within fractions. That's what the book and most other math books call complex fractions. I like to call them complicated fractions. But of course, a lot of students say any fraction is complicated. Well, no, we won't go there. So the objectives here are add and subtract rational expressions. We've been doing that. And simplify complex fractions. So let's continue. In this section, expanding from what we did in 4.3, we expand our work with adding and subtracting rational expressions, and we discussed the process of simplifying complex fractions, or complicated fractions. Before we begin, however, this seems like an appropriate time to offer a bit of advice regarding your study of algebra. This is sort of like editorial here at the beginning. Success in algebra depends on having a good understanding of the concepts and being able to perform the various computations. Yeah, okay. They're really editorializing. As for the computational work, you should adopt a carefully organized format that shows as many steps as you need in order to minimize the chances of making careless errors. Don't be skipping steps if that's going to increase your probability of making one of those careless errors. Take as many steps as you need to make sure you get it right. Don't be eager to find shortcuts. I do that, okay, for certain computations before you have the thorough understanding of these steps involved in the process. So if I start skipping too many steps, say, whoa, hold up, how did you get there? This advice is especially appropriate at the beginning of this section, and I guess we'll see why, okay? Note that the same basic procedure is followed in solving each problem. Okay? Now this is adding and subtracting rational expressions. We've already been doing this, but this is just focusing on it. Factor the denominators. I kind of like to go and factor the numerators too if it looks like it might help. But definitely you got to factor the denominators. Then you find that least common denominators, which we've been doing. Okay? It's just our denominators so far have been pretty simple when we're adding and subtracting rational expressions. Now they're going to get a little more complicated. So factor the denominators, find that least common denominator, change each fraction or rational expression to an equivalent fraction that has that least common denominator as its denominator, which basically means build the denominators to make them common, but everything you do to the denominator, you got to do to the numerator as well. So that's why you're changing the fraction to an equivalent fraction. Combine the numerators. Once you got that least common denominator, then you can add, subtract, whatever your numerators are doing, put them all over that common denominator. Simplify by performing the addition or subtraction. That means combining like terms, that kind of stuff. And you look for ways to reduce the resulting fraction. For instance, you might be able to factor that numerator. That's why, If it needed to be factored, you might want to factor it anyway, okay? Well, actually not. Usually it's best to leave the numerators alone, multiply, get those done, then at the end factor, okay? I think we'll see that happen. That's looking for ways to simplify the resulting fraction. So, they skip example 1, they skip example 2, they skip example 3. So let's do example 1 before we do example 4. Okay? Let's add this one. 8 over x squared minus 4x plus 2 over x. Now, that doesn't look too far off from what we're doing in the last section, does it? One thing that's different. Anyone pick that up? What's our first step in the procedure? What's the F word?
Factor.
All right. And what do we factor? Denominators. Can either of those denominators be factored?
Yes.
Which one? The first one. How can it be factored? Say again? I don't think so. What's the first thing we look for in factoring? Factor out an x, leaving us x minus 4. Got it. Okay? There we factored that denominator. Now we do what? Find the common denominator. Okay? Notice each of these denominators has an x, so you got to have an x there, but you only need one of them. But only one of them has an x minus 4, so this one what we're going to have to do? Multiply by x minus 4. Okay? So we multiply the denominator by x minus 4, but if we do that, what had we better do? Multiply the numerator by x minus 4. Why? Because x minus 4 over x minus 4 is 1. You can multiply by 1 anytime you want to. Okay, now we've got our least common denominator for both of those denominators, and that is x times x minus 4. What we're going to do now is add the numerators. First numerator is 8 plus what? 2x minus 8. And what does that leave us with? Yes, because 8 minus 8 is 0. 2x over x times x minus 4. Okay? And what can we do with that? Divide what? The x's. You're absolutely right, because those are multiplied. The x is multiplied by 2 here, multiplied by x minus 4 there. So divide those out, and what's your answer? 2 over x minus 4. Now this is one of those that we really need to stop and ponder just a little bit. The book isn't going to do this, I don't think. But we need to look, okay? Originally we knew x can't be 0 or x can't be positive 4. Exactly. Should have written that down. When we get to our answer here, it's obvious x can't be 4, but it's not obvious that x can't be 0. Looks like you could put a 0 in there. You have 2 over negative 4, which is negative 1/2. But guess what? You can't. Because the original problem would be undefined if you put an x equals 0. So this is one of those cases where you really do need to really think about this and say, nope, x can't be 0, can't be 4. Even though it's obvious it can't be 4 there, it still can't be 0 there. Because you can't allow an answer at the end that you couldn't allow at the beginning. Okay, a value. Okay. So they didn't do anything about that, but I just wanted to point it out to you. Any questions on that? And what did they get? 2 over x minus 4. Good for them. Now remember that every one of these examples has a what they call a classroom example for you to do. We're doing the ones here in class, so you take the classroom home, or yeah, I'd say as soon as you get out of class and have some free time, do the classroom examples while it's fresh on your mind. Okay, let's move on to erase the ink there and do yuck. All right. Example 2. A over a squared minus 4 minus 3 over a plus 2. What would be one of the first things to do? Factor! Love it. What do we factor? A plus 2 times a minus 2. That first denominator can be factored to a plus 2 times a minus 2. The second one can't be factored. It's a plus 2 is. Okay? So now that we have them factored, what do we look for? Common denominator. And what would that be? A plus 2 times a minus 2. Okay? Now, your common denominator is your first denominator. So that's the same. So it has that a on top. Okay? Minus. But in order to get this as a common denominator, what did you have to multiply the second one by? A minus 2. And if you multiply the denominator by that, what had you better do? Multiply the numerator by a minus 2 as well. So the first part of the numerator is a. What's the next part? I already put the minus in there. What follows that? 3 what? Second? Minus 3a. Minus times minus is minus 3 times negative 2 is plus 6. Very good. You have to multiply. And you multiply not just the number, but also the sign. Minus 3 times a is minus 3a. Minus 3 times minus 2 is plus 6. Okay? Keep them all. Okay. Now, are we through? What do we need to do? And what does that give you?
2a.
What sign? Negative 2a plus 6 over.
You can do a squared minus 4.
Okay, let's leave it factored for now, okay? A plus 2 times a minus 2. And here's why. What can you do with that? Yes?
I have a question.
Sure.
So if you take a text and instead of doing a plus 2 times a minus 2, if we put a squared minus 4, we kind of do wrong.
Okay. Only if this. Okay, this is why I said don't do it yet. We can factor something out of that numerator. What is it? A negative 2. So let's see what that gives us. Negative 2 times a minus 3. If that would have come up in a minus 2 rather than a minus 3, then you could have divided out, you see? But it came up a minus 3, so you could. So no, perfectly fine to leave this numerator as it is and multiply that to be a squared minus 4. Okay, the only reason I said hold off doing it, factor first, make sure there's no common factors here. If there's not, then you can go back and write it the way you want it. Yeah. So you can leave it like this, you can leave it like that, or you can multiply and get this to be a squared minus 4. And if you have the right answer, I'm going to give you credit for the right answer. I'm not the computer anywhere close to a computer. The computer is looking for one answer and one answer only. You can express these answers many ways. I'm going to give you credit if you express it correctly. Whether it's the way the test bank key has it or not, I always check and see, okay, is this just expressed a different way? Now, if it's wrong, I always figure out how to do that. But if you could have factored here, like if this had been x minus 2 here, then you get rid of that. If you'd have had the answer over a squared minus 4, no, that's not simplified because you could have factored something out. CJ, right? Okay. So that's why I said wait. Now, why did I do that? I don't even know. Oh, I'm on the wrong page. That's why I did do it. Okay. CJ. I thought I'd already put A's in for people who were absent. I usually don't do that this soon. I hadn't flipped the page. I'd gone back to see who hadn't done the quizzes and tests. Okay, so after that step, when you make sure you can't factor anything out, divide anything away, common factors, then you can go back and express it any way you want to. You can leave it like that, leave it like this, or make it minus 2a plus 6 over a squared minus 4. But I always like to factor first, make sure there's no common factors, then you can write it any way you want to, as long as it's correct. If you have it written correctly, no matter what form you use, if it's the right answer, I'll give you credit for it. If it's a wrong answer, I won't. Okay. All right, I think we still have to do example 3, so let's do that. All right. Example 3. Add this. 3n over n squared plus 6n plus 5. N squared plus 6n plus 5. Add to that 4 over n squared minus 7n minus 8. What do you reckon is going to be the first step to do? Factor. Very good. What do we factor? The denominators. Is that first factor? Denominator factor? Don't know. Let's try it. What would be the first terms? N times n. And what do you say? N plus 1 times n plus 5. That sure looks like it should work. Let's check it and see. N times n is n squared. Plus 5n plus 1n is plus 6n plus 5. Yes, that works. Okay? So we factored that one correctly. How about the second denominator? All right, she's already ahead of me here. Okay? It's n times an n. You said n minus 1. And no, I don't think so.
It's n plus 1 and minus 8.
Okay, n plus 1 and n minus 8. Let's see if that works. N times n is n squared. Minus 8n plus n is minus 7n minus 8. Now that works. Okay? Do you see any common factors? N plus 1 is common to both, so you know that's going to be part of our common denominator. It's going to have an n plus 1. What else? N plus 5, got to have an n plus 5 as well, and an n minus 8 as well. Now, we got to do whatever is necessary to make this denominator that. And what would that be? Multiplying by, again, to make this denominator look like the common denominator. Have to multiply by n minus 8. But if you multiply the denominator by n minus 8, what had you better do as well? Multiply the numerator by n minus 8. Okay? Then the second denominator, n plus 1 times n minus 8, what do you have to multiply it by to make it look like this? N plus 5. So, but if you multiply the denominator by n plus 5, what did you better do? Multiply the numerator by n plus 5 as well. Okay, now we've got our numerators set. Let's combine them together. You got to do your distributing and everything. So let's do it. What's the first one give you?
3n squared
3n squared
minus 24n
minus 24n plus 20. Very good. What can we do to simplify that? 3n squared minus 20n plus 20. I put 2. Why did I do that? Okay. 20. Okay, I just didn't finish writing, I guess. All right. Now, what's the next thing we might consider doing?
collect like terms.
Okay, didn't we just do that? We combined these two terms to give us that. Second? Factor. Let's see if we can factor. Boy, that looks pretty complicated, right? Is it Chuck? Huh? Chris. Got it. Chris Levinson. Okay. All right. We got to see if we can factor this. Now, I know that n minus 8 can't be a factor of that because 8 won't go to 20. So I'm not even going to try that. We could have possibly an n plus 1 or an n plus 5. I don't know if we will, but let's try it and see. Okay? If that's factorable, what is the first factor got to be for each of those? No, okay, n times 3n, right? That's the only way you can get 3n squared, right? Now, there's a couple ways. Okay, if you wanted this to be an n plus 1, then this has got to be a 3n. Oh my goodness. It can't be. Okay? Time out. Pause a moment here. What does this sign tell you? This is positive, so that means these two signs have to be the same, and they both have to be negative. Well, guess what? The only possibility down here is minus 8. It won't go to 20. Hang it up. Maybe it is factorable, but none of these are going to be a factor of it. Because this is a plus, that's a plus. Those both have to be negative. That's a minus. It's minus 8. So 8 won't go into 20. So hang it up. There is no simplification for this one. So you can leave it. We don't even need to try to factor anymore. Even if it's factorable, it's not going to help you. So don't waste the time, okay? You can factor if you want to. I don't think it's factorable, but you got it. So our answer is 3n squared minus 20n plus over these three factors, n plus 1 times n plus 5 times n minus 8. Now, if you multiply those out, knock yourself out. But, you know, it's not necessary. Perfectly okay to leave it in factor form. There's just no reason to factor the numerator. We know it won't produce a common factor. So, leave it alone. Let's see how they left it. Oh, look at that. They left it exactly the same way. 3n squared minus 20n plus 20 over n plus 5. They put n plus 5 first. N plus 1 times n minus 8. Done. Those are n's, not h's.
So if we factor it,
What's that?
85.
If you factor it, it's fine. Yeah. If you multiply it out the denominator, that's fine. I don't care. You know, do as much work as you want to, okay? But make sure you got right answers. That's all I'm interested in, is the right answer. Okay? All right. Now, finally, we're ready for example 4. Whoops. What I have to do is clear the screen. Okay. Now we're ready for example 4. Okay? Here's our problem. 2x squared over x fourth minus 1 plus x over x squared minus 1 minus 1 over x minus 1. What did we better do first? Factor! What? Okay. Okay, the x squared minus 1 will factor. Okay. Will the x squared x fourth minus 1 factor? I think so. Okay. So let's first factor x fourth minus, well, you could do x squared minus 1. What does that factor as? What does it factor as? No. Oh, okay, you're doing the first one. The first one is x squared minus 1 times x squared plus 1, okay? The second one factors as x minus 1 times x plus 1, okay? Are we through factoring now? How about that term? This first term right here. Yeah, you can factor that some more. So let's keep factoring until we're through factoring. And what do you have? X minus 1 times x plus 1. And then you can't factor the next one, so I'll write it down, x squared plus 1. Okay, there's our complete factorization of the denominators. Okay? What does that lead to? Why do we do what? Okay, you got to get your, why do we factor them anyway? To get the common denominator. So what's common here? Every term has an x minus 1, so I know there's going to be an x minus 1 in it. Two of the terms have x plus 1, so I know there's got to be an x plus 1 in it. This term has an x squared plus 1, okay, and this one is already covered and that one's already covered. So that's our least common denominator, which is the denominator of the first fractional form, right? So you can write down 2x squared. That's fine. But what do you need to do to get this to look like our common denominator? By? Yes, exactly. So you have to multiply this one by, I'm running out of room so I'm going to write it here, x squared plus 1. But if you multiply the denominator by that, what did you better do? Multiply the numerator by x squared plus 1. Okay? And then let's go on and do the third one too. You have a x minus 1 as your denominator, but you need that common denominator. So what do you have to multiply this by to get the common denominator? X squared plus 1, but also times x plus 1. You got to have all three terms in it. So therefore this minus 1, you had to multiply that by x squared plus 1 times x plus 1. Okay? Ooh, what a mess. Okay? In fact, it's sort of, well, let's try it. Okay? So what we have here, again, now, if you need to take more steps and more room and spread this out and make it neater, please do that, okay? I don't have a lot of room here. I'm not using it probably very well, but I'm not. So what we got, this is over that common denominator already, so that's why we wrote it down. This one now has to have that multiplied by it. So when you multiply this, what do you get? Say again? I can't hear.
What did you say?
When we multiply this, we had to multiply this denominator by this factor to get it to look like our least common. If we multiply the denominator by that, we had to multiply the numerator. So x cubed plus x. So that's the next part of our numerator, plus x cubed plus x. Very good. And then that last one. Ew. All right. I think I want to do a little scratch work over here. Let's go on and FOIL this and see what we get. FOIL these two together. What do you get? Okay, she's already multiplied by the minus, so that's fine. Minus x cubed, okay, What's the next term we would get? Minus, minus x. Then you also have a minus x squared, right? And you have a, you have a plus, but the minus makes it a minus 1. Now, she did 2 steps at once. It's fine if you wanted to. What I was going to do was first multiply this. That would give me x cubed plus x squared plus x plus 1. And then negate it with the minus sign, minus 1 here. That gives you a minus x cubed, doesn't matter the order, minus x squared, minus 1. What? Yeah.
Then it was x squared minus 1. Isn't that positive?
Okay, where is this now?
It's the towards the end.
Where?
The end. X squared minus 1.
X squared minus 1. This right here?
Yeah.
Okay. Let's see what we had. You remembered to multiply the first 2 terms by minus 1 here. You gave me a minus x cubed, and you gave me a minus x, right? But you didn't give me a minus x squared, because that minus 1 is still multiplied by that. And then the last term is a 1, but 1 times minus 1 is still minus 1. This negative sign changes all these positives to negative. Okay? So yeah, they're all negative. Now, what's the next thing we can do? Especially that numerator. Collect like terms. What like terms do you see? What's the biggest one?
X squared.
Okay, biggest exponent. Yeah, you have a plus x cubed and a minus x cubed. That adds to 0. So they go away. And then you're right. 2x squared minus x squared would be x squared, right? So now you've taken care of those 2. And then you have a plus x and a minus x. That adds to plus x and minus x adds to 0, right? You see it? Everybody? X minus x is 0, right? And then what else do you have? All you have left is a minus 1. Okay? Uh-oh, SpaghettiOs. Okay? This is over x minus 1 times x plus 1 times x squared plus 1. Now, that's what we wound up with. You think we ought to leave it like that?
No.
What should we do? Say again? Factor what? The numerator. And what does it factor as? X plus 1 times x minus 1. Look at that. These go out and those go out. So you're left with 1 over x squared plus 1. Okay? Now, again, it's kind of important. Now, the book doesn't do this, but I think it's a good practice to do, is to look at this and say, I know by looking at this denominator, x can't equal one or negative 1. Now, this can never be 0. Whatever you put in for x, you square it, it's positive, you add 1 to it, it's still positive. So that can never produce a 0. But, again, x plus 1, x minus 1, and x plus 1, x equal 1, those have to be excluded. So we really should write those down. X is not equal to plus or minus 1, okay? Those are the only things that you have to exclude. Now, this answer doesn't indicate you have to exclude anything. You look at this and say, oh, any x will work. No, x plus 1 won't work. It will work here, but it won't work back here. And that's what you were given to begin with, so you have to exclude x plus 1 and x minus 1. However, the book doesn't do this. You write that answer down, you get credit for it. Okay? but it's not a bad idea to think through. And sure enough, that's all they showed, 1 over x squared plus 1. All right, that's how we did it. Let's see how they did it. You may find they take more steps, and you say, hey, that makes it clearer to understand. So if it does, take as many steps as you need. First thing they did is write it down again, but then they proceeded to factor completely all the denominators. And this factors is x squared plus 1 times x squared minus 1. There's the x squared plus 1. The x squared minus 1 further factors be x plus 1 times x minus 1. This x squared minus 1 factors is x plus 1 times x minus 1. This one won't factor, so you just write it down. So factor the denominator, done it. Next step, this is review. Next step, second, common denominator. And what will it be? It has to have x squared plus 1, and x plus 1, and an x minus 1. Well, that's it. All these are included there, that's included there, so therefore that is your least common denominator. So I'll let them write it down. Ooh, they jumped to another page. Okay? So the least common denominator is that first denominator, x squared plus 1 times x minus 1 times x plus 1. So that numerator stays just like it is because that was the original thing. However, this one didn't have the x squared plus 1, so you're going to multiply the denominator by x squared plus 1, which means you multiply the numerator by x squared plus 1. Now, I don't do it the same way they do, but we're doing the same thing. This one, on the other hand, only had an x minus 1, so you have to multiply by x squared plus 1 times the x plus 1. But if you multiply the denominator by that, you got to multiply the numerator as well. So that's now our expanded form. A lot like we did it, though I took a lot less room than they did because I didn't have as much room to write, and I don't write as small as they do. Okay? So now we combine things. We've got our least common denominator, so we put everything over that least common denominator, and we do the 2x squared plus the product of those, or x times x squared plus 1 over that denominator. Plus, or minus 1, they left off the 1 here, because you don't need to write it in and so forth. This times that. Okay? So again, take as many steps as you need. If this makes it clear for you, go for it. Okay? So now we're going to clear parentheses, distribute 2x squared plus x cubed plus x, and then that minus 1 negates everything in there, multiply those together, boil them, and they all come out positive, but the minus 1 changes them all to negative. Okay? So that's what you got. But at this point, you can combine like terms, and that gives you 2x squared minus x squared is x squared. The x cubed plus minus x cubed goes to 0. X minus x, that goes to 0. You're left with a minus 1. And that gives you that. Now, simplify by factoring the numerator as well, and that gives you x plus 1 times x minus 1, which divides out here and here, and just leaves you 1 over x squared plus 1. But, I hate to keep saying this, but you have to remember, because they were originally in the denominators, x cannot equal negative 1, it cannot equal positive 1, even though this doesn't look like there's any problem with that at all, you still have to exclude it. The book does it, so you don't have to, but it's just not a bad thing to think through. Okay? That was example 4. Now we're moving to simplifying what they call complex fractions. I call them complicated fractions. They're fractions within fractions. Here are some examples of them. This is complex fractions are fractional forms that contain rational numbers or rational expressions in the numerators and or the denominators. Here are some examples of complex fractions. 4 over x over 2 over xy. Okay? Obviously, a fraction in the numerator, a fraction form in the denominator, a rational expression in the numerator, and a rational expression in the denominator, and then you've got rational expressions and two rational expressions. Same thing here, only here you have a sum of two rational numbers divided by a difference in two rational numbers. So you have a fractional form that contains denominators in both. Same here. Here we have variable denominators. That one, you have a fractional form in the numerator, but not one in the denominator. Of course, you still do. That's over 1, right? And here we have a whole number, or a integer in the numerator without a fractional form, but a fractional form in the denominator. But then 2, this is minus 3 over 1. So that is a fractional form. So let me give you a few hints. They're going to do this later in the text, how you go about solving this. Here's my rule of thumb. Look at all the denominators. Let's just take this one. Here's a denominator, there's a denominator. Find the least common denominator. What is it? X times y. Multiply the numerator times x times y and the denominator times x times y, because you're multiplying by xy over xy. That's 1. Okay? So that's a perfectly legal thing to do. Up here, the x's go out. I'll write them down. So you multiply, find that least common denominator and multiply by it. xy over xy. And that is 1. Okay, so that's why it's legal to do this. Divide out one of the x's here and divide out both of them here. And what you have here is 4y over 2. Which now you can divide out to 2, and that gives you 2y over 1, or just 2y. Okay? So the general rule, find the least common denominator of all your denominators, and then multiply that in the numerator and denominator, which is legal because that is 1. Okay? And then simplify. Okay? Now, the next one. Let's do the same rule. There is another way to do this, and the book will show it to you. This seems to work to do it. What would I suggest? Find the least common denominator of all your denominators. And what would that be? Say again? Can't hear. 2, no. Okay, it has to be common to everything. 2 is in here, and it's in here, but 4 is in here, it's not in there. So 2 is not the, it's a common factor in all the denominators, but it's not the least common denominator. It's got to be at least the biggest one. But that's not it, because 6 won't go into 8. 2 will go into 8, 4 will go into 8, but 6 won't. 24, you got it. So let's multiply. Is it time? No, it isn't. We got a minute. Let's multiply the numerator by 24 and the denominator by 24. Least common denominator. Okay, what this gives you, 2 will go into 24 12 times, plus 4 will go into 24 6 times. 6 times 3 is 18. Divided by 6 will go into 24 4 times. 4 times 5 is 20. And 8 will go into 24 3 times, but you got a minus sign there. 3 times 3 is 9. So this gives you 30 over 21. Can that reduce any? By what? 3 will go into 30. 10 times 3 will go into 21. 7 times. That gives you 10 sevenths. Okay? Now I think we're out of time. So, we're going to start next time, and we're going to continue this practice. In fact, these are the examples, so we won't go back and do the one. I'll show you what they are. Okay, but I do want to give you a few homework exercises. Okay, now some of you may have come in late, but let me see. Homework exercises, do any of the odds 1 through 39. There's a whole bunch of those. and then start doing some of the odds, 41, 43, 45. Do as many of those as you can, but we'll get to do some of the rest of them later. Okay? Now, did anyone come in after I passed out the quiz? Did anyone not get a quiz? Okay. Then before you go, let's make sure you get a quiz. Who needed it? Anyone else came in after again? Everybody got a quiz? Do a weekly. What's that? You are done. Okay. You know what your score is?
No, that's
Huh? Okay. Remind me of your last name. Huh? King? Oh, I knew I was going to do that at some point in the morning. There you are. Okay. Right now you got a 60. And you left this one, that one, that one, that one blank. As well as, looks like you answered all those. So if you want to work on these, you certainly can. You want to? It may bring up a 60. You don't have to do it today, but you, when? Monday? When? After class? Or? Okay, yeah, that'll be fine. I just didn't want to record it until I was sure you were satisfied with that grade. Huh? You want to see your test too? Huh? I can't hear you.
I said I wanted to tell you I was done.
You want to see if you're done. Okay, did I not have you? Okay.
No, I said I'm done.
Oh, you're done.
Uh-huh.
And I don't have a scoring for you?
I don't think so.
Okay. And remind me of your last name. I know you're Ari. Huh? Piglet. Okay. I remembered it started with a P, but I couldn't remember what it was. There you are. Okay, what you got so far is a 54. You left off number 5 completely. Maybe the only one. Nope, 16 and 17. And 19 and 20. Huh?
Okay.
You gonna go with that, or you gonna do any more?
I'm just going with that because I don't understand probably.
Okay. Well, we're still doing them, aren't we? So that's why I say it's a good idea to get it down.
I'll do it later.
Okay, so you want me to give you the 6? I thought it was 54. That's why I didn't want to write it down. But you want it?
I'll finish it later.
You will finish it later. Okay. Okay. I think that's a good move. Because I hate getting bad grades. I just hate it, you know. I'll do it if you tell me to, but